We're now going to look at solving systems of equations having three variables. It's going to be very important that you stay organized in this process. If you will follow these directions, it should help your organization. First, label the equations 1, 2, and 3. Then from the beginning, choose a letter to eliminate. Choose two of the three equations and eliminate that letter. Then you're going to choose two different equations than you chose in step 3 and eliminate that letter again. You're going to take your two results from steps 3 and 4 and combine the resulting equations. This will bring us back to a problem of solving two equations with two unknowns as we just finished in the previous section. You're going to find the last letter by back substitution. Always check your answers in all the equations. Let's get into an example of this. For the first equation, let's use x minus 2y plus 3z equals 11. For the second equation, 4x plus 2y minus 3z equals 4. And for the third equation, 3x plus 3y minus z equals 4. We're looking for an ordered triplet, and that ordered triplet will usually go in alphabetical order. So we're going to do x, y, and z. I'm going to choose a letter to eliminate from the beginning. And to me, the z's are going to look the easiest to eliminate. So I'm going to choose z. Once I chose z, I'm going to take two of those equations to eliminate the z. If you will look at equations 1 and 2, nothing is going to be required by multiplication to eliminate the z's, as they will eliminate themselves. So I'm going to copy down equation 1, and I'm going to copy down equation 2. I'm going to add them together, and at this point I'll have 5x. You'll notice the y's will eliminate, so will the z's, equals 15. So there's your first result. Matter of fact, we can go a little bit further and go ahead and say that we know that x has to equal 3. Now, we need to choose two different equations. We've already chose 1 and 2. We either need to choose 1 and 3 or 2 and 3 to eliminate the z again. I'm going to use equations 1 and 3. If I'm going to look at the z's, I have a positive 3z and a negative z. So in order to eliminate those, I need to multiply equation 3 times 3. I'll copy equation 1 again. Then I'll multiply 3 times the whole equation of 3. So 3 times 3x is 9x, 3 times 3y is 9y, 3 times negative z is negative 3z, and 3 times 4 is going to give us 12. When I add those two equations together, I'm going to have 10x plus 7y, the z's will cancel, will equal 23. So my two results that I'm going to take together are the fact that x equals 3 and 10x plus 7y equals 23. I'm taking this result, we can call this 4 and 5 if you want, to help you stay organized. We have to solve 4 and 5 before we can go back to the original problem. Well, this one's not going to be hard. We can just substitute the 3 in for the x into equation 5. We'll have 10 times 3 plus 7y equals 23. That's 30 plus 7y equals 23. When I subtract 30 from both sides, I'm going to have 7y will equal a negative 7. Therefore, I know that y has to equal a negative 1 when I divide. At this point, I have solved for the x and the y, so I have finished with equations 4 and 5. And my last step is to go back and back substitute for the last letter. The last letter you find will always be the first letter you chose to eliminate. You can go back into any of the original equations. I'm going to take equation 1 of x minus 2y plus 3z will equal 11. I now know that the x is 3. I know that the y is negative 1, and I'm solving for the z. Cleaning this up, I have 3 plus 2 plus 3z equals 11. That's 5 plus 3z equals 11. When I subtract 5, I'm going to have 3z will equal 6. Therefore, I know that z has to equal 2. So 3 is our x, negative 1 is our y, and our z is 2. Always good to go back and check this into your original problems. Check all answers into all equations. Using a calculator can make this very simple. Taking the first equation, my x is 3 minus 2 times my y, which is negative 1, plus 3 times my z, which is 2, will give me the answer of 11, so it works for equation 1. Equation 2 is 4 times my x, which is 3, plus 2 times my y, which is negative 1, minus 3 times my z, which is 2, and that gives me the answer of 4, so it works for equation 2. Equation 3 is 3 times my x, which is 3, plus 3 times my y, which is negative 1, minus my z, which is 2, equals 4 again. So we know we have the correct solution there. Let's go ahead and work another one of these all the way through. In this example, let's take x plus y plus z equals 6 is equation 1. Equation 2, 2x plus y plus z equals negative 3. And equation 3, x minus 2y plus 3z equals 6. Choose a letter from the beginning to eliminate. None of them look a little or easier than any of the rest, so I'm going to, just by default, I'm going to choose x. I need to take two equations and eliminate the x. So if I look at equations 1 and 2, and I look at those x's, I have 1x and 2x. The least common multiple there is going to be 2. Therefore, I'm going to make one of them a positive 2 and one of them a negative 2. 2 is already a positive 2, so if I look at 1 to make it a negative 2, I'm going to have to multiply the whole equation by negative 2, which will give negative 2x minus 2y minus 2z is going to equal a negative 12. Equation 2 is just 2x plus y plus z will equal a negative 3, and when I add those together, my x's eliminate. I have negative 1y minus 1z will equal a negative 15. Now I have to eliminate the x again using two different equations. This time I'm going to look at equations 2 and 3. If I look at equations 2 and 3, again, the least common multiple of 2x and x is going to be 2. So 2 I'm going to leave alone as 2x. I'm going to have to make 3 into a negative 2x. So I want to multiply equation 3 by a negative 2, which will give me negative 2x plus 4y minus 6z will equal a negative 12. Just copying down equation 2 again because it was fine. Add those two equations together. Notice that the x eliminates. We are left with 5y minus 5z equals negative 15. So we have two results. The next step is going to be to take those two results, I'm going to call the first one 4 and 5, and solve that problem. It becomes a problem within a problem of negative y minus z equals negative 15, and 5y minus 5z equals negative 15. I'm going to choose to eliminate the y. So my least common multiple of negative 1 and 5 is going to be 5. Equation 5 can stand alone. Equation 4 I'm going to need to make into a negative 5y. That's going to entail me multiplying the whole equation by 5. That's going to give me a negative 5y minus 5z equals negative 75. Combining that with 5y minus 5z equaling negative 15, adding those together, my y's eliminate. I'm left with negative 10z equals negative 90. Therefore, I know that z has to equal a positive 9. I'm going to go back up to the original problem. I know that my z is 9. Now I have to finish out this problem and solve for y. I'm going to back substitute into equation 4, which is negative 1y minus 1z equals negative 15. Plug in the fact that I know now that z is equal to a 9. That's going to give me negative 1y minus 9 equals negative 15. When I add 9 to both sides, that's going to give me that negative 1y will equal negative 6. And you should know, therefore, that y equals 6. So we have finished equations 4 and 5, solving for y and z. The last step is to back substitute into either one of the original equations. I always just choose equation 1. Now that we know 2 of the letters, it's easy to find the third one. So I'm going to have x plus 6 plus 9 will equal 6. X plus 15 will equal 6. When I subtract 15 from both sides, I'm going to realize that x is going to equal to a negative 9. Now, we want to call our calculator up and make sure that we got the correct result. Checking in equation 1, my x is negative 9, plus my y, which is 6, plus my z, which is 9, gives me the answer of 6. In equation 2, 2 times my x, which is negative 9, plus my y, which is 6, plus my z, which is 9, gives me the answer of negative 3. And the last equation, x, which is negative 9, minus 2 times my y, which is 6, plus 3 times my z, which is 9, does give me the result of 6. So I know that it works in all three equations. Let's look at one more equation and work it all the way through. This time I want us to look at x plus 2y minus z equals a negative 8. 2x minus y plus z equals a 4. And 8x plus y plus z equals a 2. Again, we need to stay organized, so let's label these 1, 2, and 3. The next thing we do is choose a letter to eliminate. I see that my z's all have the coefficient of 1, so I think the z's would probably be the easiest. I'm going to choose the letter z to eliminate. If I just copy down 1 and 2, I will notice by looking at those z's, a negative z and a positive z will cancel each other out. So I can just copy down 1 and 2 and add those equations together to eliminate my z. When I add them together, I'm going to have 3 of my x's plus 1y, my z's eliminate, equals negative 4. Now I have to choose z again and take 2 different equations. Well, if I look at the equations this time, if I look at equation 1 and equation 3, if I add those together just like they are, the z will eliminate itself. So I'm just going to copy down 1 and 3 and add those together. When I add them together, that's going to give me 9 of my x's, 3 of my y's, my z's will cancel, will equal a negative 6. At this point, I have 2 results. I'm going to go ahead and call those 4 and 5. I need to work 4 and 5 and finish this problem out of 3x plus y equals negative 4 and 9x plus 3y equals negative 6. I'm going to choose to eliminate the x's. If I look at my x's, equation 5 has a 9, so I can make equation 4 have a negative 9 by multiplying the equation by negative 3, which will give me negative 9x minus 3y equals a positive 12. keeping equation 5 the same as 9x plus 3y equals -6. And when I add them together, the x's cancel. You will notice at this point the y's also cancel. That means the left side of your equation is 0 and the right-hand side of your equation is 6. At this point, all your letters have dropped off, and what's left is false. If we remember from two equations, two unknowns, that means that those two lines are parallel and there is no solution. So there is no solution to this problem. Stay organized on this, step by step. These are tedious, but they're not too difficult.